Welcome back, everyone. In this lecture, we're going to discuss the details behind extracting features from text data, mainly the theory and intuition behind the general processes. Now, again, as we keep mentioning, most classic machine learning algorithms can't take in raw string text as data. Instead, what we need to do is perform some sort of feature extraction from the raw text in order to pass in numerical features to the machine learning algorithm. So when we're talking about feature extraction from raw string text, really what we're talking about is some sort of transformation to go from the variety of strings and words to numbers, something the machine learning model can understand. Now there's two main methods of doing this. One is the simpler method of count vectorization, and the second one is known as TF-IDF, or term frequency inverse document frequency. Let's start with count vectorization. Count vectorization is actually a very simple process. Imagine that we have three documents, where each document is actually just a simple sentence. So we have three sentences here: you are good, I feel good, I am good. And what we want to do is be able to extract features from this in order to create a numeric matrix out of this text information. So what count vectorization is going to do is start off by creating a vocabulary of all the possible words across all the documents. So if we take a look at all these documents, that is these three lines as three separate documents, and the vocabulary across all the documents, we end up with these 6 unique words. So out of these 6 unique words, we should be able to build out those 3 documents. Keep in mind, not every document uses every word in the total vocabulary. So what we could do here is simply count out how many times each word occurs in each document. So for the first one, you are good, we can see here that we have one instance of you, one instance of are, and one instance of good, with the rest of the words being 0 count. And we do this for every single document in our group of documents. Note that we're also going to do this for every single possible word across all the documents. Now with that idea in mind, you should note that most values are going to be 0. You can see here that we have a lot of zeros, and these are 3 very simple sentences that actually share a lot of the words. So you can imagine if you were doing this with really long documents that contained hundreds or thousands of words, then these matrices are going to be just full of zeros, because it's unlikely that every single document uses every single available word. Now in scikit-learn, you can imagine that if we actually just call count vectorization, we would have a list of messages, such as text messages or tweets, and then it would transform it into what is known as the document term matrix, or DTM. And we can see here that we have all the possible words across all the documents, and again, just a frequency count. And note, it's not just ones and zeros. If a word occurs more than one time in a document, it's going to have 2 or 3 or 4, etc. So it's not just a 1 or 0 if the word occurred, it's actually a count. How many times does this word occur in this particular document? Now we should note that count vectorization essentially treats every word as a feature, with the frequency counts acting as a strength of that feature or word. And for larger documents, matrices are stored as a sparse matrix to save space. Since so many values are going to be 0, then it makes more sense that instead of we store all these zeros, there are mathematical ways to actually reduce that to what is known as a sparse matrix to save space. Now what are the issues we need to consider for the count vectorization model? Well, we do have the issue of very common words, such as the, and about, and so on. Should we actually be counting these? Are they very useful, since they're going to show up a bunch of times throughout the documents, and they don't actually inform us of any unique characteristics of most documents? And we should also think about the documents themselves. Are there words that are common to a particular set of documents? For example, let's say we have a bunch of text documents that we're trying to classify into different sports articles, like some articles on baseball, some articles on basketball, some articles on soccer, and so on. We should note there's going to be some words that appear often throughout all the documents, such as run or such as ball, and that may actually not be too important of a word for this particular set of documents. So let's talk about that first potential issue. Well, this is actually easy to fix if you have a set of what is known as stop words. Stop words are words common enough throughout a language that it is usually safe to remove them and not consider them as important. Words such as and the are so common throughout all the documents, usually in a corpus of text documents, that it's not actually important to try to actually count the number of frequencies or number of times they occur throughout many documents. And most natural language processes or libraries are going to have built-in lists of common stop words. Now we can address the issue of document frequency by using a 𝒕𝒓/𝒂𝒕𝒓 vectorization process, or term frequency inverse document frequency. So instead of filling that document term matrix with word frequency counts, it's going to calculate term frequency inverse document frequency value for each word. And this is known as 𝒕𝒓/𝒂𝒕𝒓. So what's the idea behind 𝒕𝒓/𝒂𝒕𝒓? And how does this actually address the issue of the situation where you have, for instance, run being very common across a bunch of documents, but it's not also a stop word? Well, let's first think of the two separate instances of term frequency versus inverse document frequency. Term frequency is just what we were discussing. It's the raw count of a term in a document. So we can think of 𝒕𝒓 as a function of t and d, where t is the term itself and it occurs x amount of times in document d. This is actually just count vectorization. This is what we just did. So it's the frequency of each term in the document. Now, what about if we start considering the documents in the whole? Well, term frequency alone isn't enough for a thorough feature analysis of text. So we have that issue of very common words, those stop words like or the, and we also have the issue of words that are common across the documents. So the stop word issue like the is so common that term frequency is not enough to really emphasize documents. And there was the issue of that group of documents where non-stop words are common throughout all the documents. So for example, that word run in documents about various sports. So with count vectorization, you're just considering the words within a single document. What would be nice if we could start thinking about those words and their relationship across all the documents. This is where an inverse document frequency factor is really important. So what an inverse document frequency factor is going to do is it's going to diminish the weight of terms that occur very frequently in the document set. And it's going to increase the weight of the terms that occur rarely. So again, what's going to happen is if you have some words that are super common across all the documents, such as the word run or the word ball across a bunch of sports articles, that term is actually then not so important at distinguishing one set of documents from another. But if you have something like goalposts, well, we know that's only going to show up in certain sports, and suddenly that's not found in all the documents. And so it's going to increase the weight of those terms that occur rarely. So really common words across all the documents, they're weighted lower, and very unique words across only certain documents are weighted higher. So we want these distinguishing words or distinguishing features. So what is that inverse document frequency? Formally speaking, it is the logarithmically scaled inverse fraction of the documents that contain the word, which is obtained by dividing the total number of documents by the number of documents containing the term, and then taking the logarithm of that quotient. So what is this in kind of more simple laid out terms? The inverse document frequency, again, is just a count of how common or rare a word is in the entire document set. That is speaking that the closer it is to 0, the more common a word is. Calculated by taking the total number of documents, dividing it by the number of documents that contain that specific word, and then calculating the logarithm. And then 𝒕𝒓/𝒂𝒕𝒓 is simply the term frequency multiplied by the inverse document frequency. And so here we have the equations where 𝒕𝒓/𝒂𝒕𝒓 is simply equal to TF multiplied by IDF. And we can see here the actual formally mathematical way of writing inverse document frequency. But recall, it's simply done or calculated by taking the total number of documents, dividing it by the number of documents that contain that specific word, and then calculating the logarithm. And that's what's being shown here in terms of T, D, and capital D. Now, fortunately, scikit-learn can calculate all of these terms for us through the use of its API. It has three main methods: count vectorization, 𝒕𝒓/𝒂𝒕𝒓 transformer, and 𝒕𝒓/𝒂𝒕𝒓 vectorization. And we'll talk about the differences between all three of those later on. But you should notice that how similar the syntax is to our previous use of machine learning models in scikit-learn. It's going to feel very natural. Essentially what it's going to look like is we'll say from sklearn.featureExtraction.text import one of the class options like 𝒕𝒓/𝒂𝒕𝒓 vectorizer. You'll create an instance of the vectorizer, and then you'll call fit transform on the messages. And note what happens here. Instead of getting a bunch of zeros, ones, twos, threes, whole numbers, instead you get these ratios essentially telling you that the words are either unique or not so unique across all the documents. And then it also takes into account how many times those words show up in any particular document. So it's combining count vectorization, that is that term frequency, along with the idea of how often any particular word shows up across all the documents. So TF-IDF allows us to understand the context of words across an entire corpus of documents instead of just its relative importance in a single document. Now coming up next, we're going to begin to explore how to perform these operations with Python and scikit-learn. I'll see you at the next lecture.